All right, our next one of our 12 functions we're going to learn about is the absolute value function. So I am going to start by writing that f of x is equal to the absolute value of x. So these are our absolute value bars. Remember that whenever we go into the bars, we always come out positive. So we're going to start with our grid. And I am just going to make a small table on the side right here so that we remember what happens. So this is x, and then these are our y's with the absolute value of x. So I'm going to start with -1. So when I put in a -1, that comes out +1. 0. The absolute value of 0 is 0. When I put in a 1, that's also going to come out 1. So no matter whether you're negative or positive, you always come out as a positive value. If I put in 2, I come out as a +2. So graphing our function, we have -1, 1, 0, 0, 1, 1, 2, 2. If I put in a -2, I have to come out positive. So this is going to become the absolute value function, just like this. Okay, so its symbol on absolute value functions is always going to be a V symbol. Okay, so when we see a V, we know we're doing absolute value. We want to remember that its graphing pattern is going to be 1 right, 1 up, 1 right, 1 up, 1 right, 1 up. Don't confuse this with slope. This is just its graphing pattern for when we do transformations, okay? So what you may want to do over here on the side is I'm going to do graphing pattern. If you need to write, don't do slope, that's fine. So the graphing pattern will always stay 1 right, 1 up. Oops. Okay, and you'll see this pattern is going to change on parabolas and different things, and sometimes we're not even going to use its graphing pattern, we're just going to use some points. All right, so our first thing that we need to answer is our domain. So what are all the x's and y's that we're going to use, or y's are arranged? So there is going to be, all of them are going from -infinity to +infinity. So that's our domain. Our range is only the zeros and above. So instead of using parentheses, we're going to use a bracket for the 0, and then we're going to use +infinity for its upper. Remember that when we do ranges, we're going to go bottom to top. When we go domain, we're going to go left to right. Okay, you may want to put a star on that so you're not forgetting as we go through the different graphs. Next one is increasing. Okay, meaning as my x's are going up, what are my y's doing? So I am increasing from 0 to +infinity, and then I'm going to look at decreasing. Now when I'm decreasing, remember that my x's are getting higher this way, but my y values, every time I move 1 to the right to get higher, the graph is actually coming down 1. So I'm going to be decreasing from -infinity to 0, like that. All right, next up, hold on one second. I'm using a cheat sheet so I know what our order of our information is. All right, so we want to do symmetry next. I want us to have the same habit on every picture. So on our symmetry, we can fold it in on itself, kind of like a butterfly. So our symmetry is going to be the y-axis. Remember, the y-axis is written as x equals 0. You'll see it both ways, so watch out. X equals 0 is a vertical line. We know this from Algebra 1. This is an even graph because it has a end behavior of both going up. Okay, so this is an even graph. It is going to be bounded. All right, so it's bounded from below. So I'm just going to write below. And I'm going to write at y equals 0. All right, so once I get to my x-axis, I am done. So I'm going to be below this as its bounded area. Extrema, okay, so it has a minimum, okay, because this is the lowest point on it for sure, and it is at 0, 0. We have no horizontal asymptote. We have no vertical asymptote. All right. And the last thing we want to talk about is the end behavior. Okay, and remember we write it in limit. Okay, so the limit, sorry, let me change my pen color. The limit as x is approaching negative infinity, so as my values get more negative, then my function becomes more positive. Okay, so as I go negative, it becomes positive. The limit as x is getting more positive, so as x is coming this direction, then I can see that f of x is getting also more positive. So the end behavior in this case is they are both going positive. Okay? All right, best of luck.